Hey everybody, welcome to semester 2, day 7 of summer school geometry. Today we're going to be talking about the various three-dimensional shapes in geometry and how to calculate their volume. So at the top here, I have the 4 basic types of three-dimensional shapes listed, and we're going to go over the formulas for each of these shapes. The first one is a rectangular prism, which you're probably familiar with. When we draw a rectangular prism, we label the sides or the dimensions using specific names. So the height is the vertical length right here. The length is usually the longer side, and the width is usually this dimension right here, depending on how the picture is drawn. But the volume, calculating that is very straightforward. You just multiply all 3 of these dimensions with each other. So that ends up being length times width times height. Pretty straightforward for the rectangular prism and finding its volume. Then we have the cylinder. For the cylinder, we need to know 2 dimensions. We need to know, first of all, what is the height of that cylinder from the top to the bottom. And we also need to know what is the radius. Those are the 2 things you need to know. And the way you find the volume is very similar to a circle. You start with pi r squared, which is the area of the circle, the area of this circle, for example, and then you multiply by the height. So that gives you all of these circles that you would kind of add up in between here to get to the full volume. So times the height there. There's the volume of a cylinder. Next, we have the cone, which is similar to a cylinder. These all kind of interconnect with each other. Again, we need to know the same 2 things. We need to know what's the radius, but we also need to know the height. But here, the height is still the vertical distance. So usually in a cone, you see the height drawn as this line going straight from the center of the circle at the bottom, straight up to the corner edge up here, the place where the cone meets these 2 lines here. That's going to be the height, the vertical distance. This one, we're going to have pi r squared again. Just like I said, these are all connected with each other. The only thing that's different here is we do times h over 3. We divide by 3 because the formula for a cone, if you think about the volume here, it's less than the volume of a cylinder. So that's why we divide by this 3 here. And then the last one is a sphere. If you think about any object that's a sphere, like a basketball or a tennis ball, and you wanted to calculate its volume, we need to know just 1 dimension, and that's the radius of the sphere. The way we figure this out is we do 4/3 times pi r to the power of 3 now. So be very careful there with the sphere. We have an exponent of 3, but we just need to only know the radius, and then we're good to go to find the volume. So we're going to work 4 different examples here, 1 of each of those objects. So a rectangular prism is this first example. All we have to do is just identify the 3 dimensions, 11, 13, and 2. So your volume is going to be each of those multiplied, length times width times height. So the length is 11, the width is 2, and the height is 13. And you can calculate that using your calculator to get whatever that final answer is. And the way we write the units is we write cubic centimeters or centimeters with this little 3 here. That means the 3rd dimension. Okay, so you can multiply these. It's that number, centimeters cubed or cubic centimeters. That's what that means. Then we have a cylinder. It tells us the base diameter is 4 centimeters. So I'm going to draw something that I would think would be 4 centimeters. And half of it would be 2. This is my radius. Okay, so that's halfway there. And the cylinder has a height of 2 centimeters as well. So I'm going to draw a height of 2 centimeters. And now I'm going to draw what I think my cylinder would look like. Something like this maybe. So there's my cylinder. I have my radius and I have my height. That's the 2 things we need to know here. So the volume of the cylinder is pi r squared times h. So in this case, we have pi times the radius squared times the height, which is 2. So this ends up becoming 4 times 2, which is 8, and then pi. To round to the nearest tenths place, we would convert this to a decimal. You just type this into your calculator and get the decimal value. The third shape we have here is a right circular cone. So what that means is we have the base of our cone. Right circular means the base is a circle, and we form a right angle with the height, like that. You can kind of see that right triangle in there. Now we have the radius and the height there. We need to think about what the dimensions are. So it tells me the height is 9.5, so that's good. H is 9.5. And it also tells me the circumference of the base is 3.4. So be careful here. Their circumference is the length around that circle at the bottom, 3.4. The formula for circumference, which we learned earlier a few days ago, was 2 pi times the r, and I need to figure out what r is, so this equation will help me do that. My r is going to be equal to, let me write it the other way, sorry. If I wanted to figure out what r was, I would divide by 3.4 by 2 pi, just like that. And so if I did that, that gives me 0.541. 0.541. So there's my radius, and I have my height. Now we just need to use our formula here. Pi r squared times h over 3. And now we just replace the values of r and h with the r is going to be 0.541. And our h we said was 9.5 over 3. And once again, you can, if you need to round to the nearest tenth, we would type all this into our calculator and we can get our answer and round to that first decimal place. And the last problem, we have a hemisphere. Hemisphere means half. So I'm going to draw just half of a sphere. Just like that. And we only need to know the radius. If it tells me the diameter, I know the radius is half of that. So my radius in this case is going to be half of 8.9, which is 4.45. That's my radius. Now what I want to do is just use my formula here, but let's be careful now. So there's a couple of things we have to pay attention to. Like I said earlier, 4/3 pi r to the power of 3. That's the volume of a sphere. I need to determine a hemisphere. That's half of it, not the full one. So what I'm going to do is I'm going to multiply all of this times 1/2 to get half of that value of a sphere. The rest of this is just replacing values. So I get 4/3 pi times 4.45 to the power of 3 multiplied by 1/2, and that'll give me the hemisphere. And once again, we can type this into our calculator, get our value, and we round to the nearest tenth, which is the first decimal place. And if you have any questions about any of these problems or anything you see on your Delta Math later today while you're working, please don't hesitate to email me, or you can send me a message on Canvas, and here's my email if you need to email me.